Structural details, that is all I wanted to say. The second question is also crucial. This is a detailed preparation process for platinum catalysis. Hydrogen gas sprayed onto platinum. Want to ignite instantly. It is impossible to achieve this using ordinary platinum. We need extremely fine amounts of elemental platinum, a fluffy porous structure with a higher specific surface area. The key to replicating this phenomenon is, could it be said, do we need to grind platinum into powder for this? This doesn't seem like a very wise choice to me. I used platinum compounds anyway to restore the fine platinum particles. What I'm holding now is chloroplatinic acid. Generally, it is stored in a glass-sealed container. This thing has extremely strong water absorption. Once opened and exposed to the environment, within minutes, the surface will appear water absorption. Therefore, the whole process needs to be fast. Dissolve chloroplatinic acid in purified water. If you intend to use it for catalytic purposes, 1 gram of chloroplatinic acid. Use 100 to 200 milliliters. Just use purified water to dissolve it. It depends on the specific usage scenario. After preparing the chloroplatinic acid solution, the next step is to select a suitable carrier. The recommended structure is cotton-like and resistant to certain high temperatures. I used fiberglass. Anyway, I've never tried asbestos. Draw chloroplatinic acid solution using a dropper. Simply moisten the glass wool instead of choosing direct soaking. This is because the cotton-like structure absorbs a large amount of liquid. This causes unnecessary waste. In the early stages, we can compress the glass wool to make it dense. On the one hand, it saves reagents. On the other hand, it increases the mechanical properties of the material. This greatly increases its durability. In my experience, experiments to catalyze hydrogen combustion using platinum, you can definitely add more water to the chloroplatinic acid solution. The ice could vaguely see a pale yellow tinge. This platinum content is sufficient. Choose to air dry the platinum cotton, or you can dry it in the oven. Do not rush the drying process. Excessive baking temperature due to the Leidenfrost effect. This causes liquid to spread. This leads to uneven distribution of platinum particles in the material. If you want to increase the concentration of chloroplatinic acid solution, or to make it recrystallize to store in solid state, moisture can be removed by natural evaporation or heating. There are many methods for reducing chloroplatinic acid to elemental platinum. I will only recommend one here. That is real burning. A layer of black substance appeared where the flames had burned. These are the restored tiny platinum particles. These tiny metal particles have a porous structure. This results in very low light reflectivity, so it appears black. This state of platinum is also called platinum black. It is not due to incomplete combustion of the gas, the remaining black charcoal. On this point of view, we can burn untreated chloroplatinic acid solution. Evidence was found on the glass wool. The platinum cotton has now been completed. Let's test it with hydrogen gas. Everything is within reason. Despite a large amount of platinum black deposited on the surface, its internal catalytic capacity remains strong. Why can platinum react with hydrogen and oxygen at room temperature? This is due to the unique structure of platinum's electron orbitals. This enables it to absorb a variety of gases. This also includes hydrogen and oxygen, and it can combine hydrogen and oxygen molecules, dissociation into individual atoms. This allows the reaction to occur at relatively low temperatures. The entire catalytic mechanism cannot be explained in just a few words. Those who are interested can look up relevant information. Except for hydrogen, platinum can also be used to catalyze other substances, oxidation reactions of hydrogen-containing organic compounds. From this, you can see platinum cotton in the conical flask containing alcohol and kerosene glows and generates heat. However, all of these have a prerequisite. That means the platinum cotton needs to be heated with a flame. You need to put it into the bottle quickly. We move on to the next chapter.